We're ready. One, and two.
If there are questions or comments at any time, feel free to interrupt. So we're going to finish up the information visualization material today, or this evening rather. So looking back, we introduced information visualization, then we jumped into hierarchical data viz techniques, then we jumped into multivariate data viz techniques. We looked at graphs as well. All are great candidates for assignment 1. And we looked a little bit at interaction, and then this last topic is focus and context, which you've already been exposed to already, but now we're going to give you lots of different examples of this focus and context idea. So the idea behind focus and context is that there are a few ideas behind this and motivations, but generally speaking, not all data is of equal importance. Usually we have a large, complicated data set and we're searching for some special behaviors. We want to answer some special questions. We want to confirm or refute hypotheses. So we're searching for something inside of a large data set. And that pattern or outlier that we're searching for is more important than the rest. And sometimes we won't have enough screen space to plot all the data anyways. So we could use these focus and context visualizations where the focus is rendered, for example, in color, and then the context data is rendered as grayscale. And we'll see lots of different examples. But the focus is the important data and the important part of the visual design, and then the context is the less important part of the imagery. And we have lots of cases when this is useful. So for example, when the number of data items actually exceeds the number of pixels on screen space, when some data is more important than others. Now we also avoid this problem and this confusion if we use a binary segmentation of important and unimportant data. It's easy to get lost. So if you show somebody only the focus, you can get lost. And that's something you're very familiar with when you're using your mobile phone. Whenever you try to look at a map on a mobile phone, it's more difficult because you have such a small space. Like, it's much nicer to look at a map with more context, more of the surrounding space, like on a laptop or on a screen. Right? It's more difficult on a mobile phone. However, on a mobile phone, for example, you cannot get all the data that you want. If you cannot see all the context. And there might be times where if you show only the overview, you cannot get all the detail you want in a region of interest that you're focusing on, or that happens to be very important. So focus and context is kind of a way to resolve this tension. Can we get the focus or the important stuff that we're interested in great detail and enough detail to satisfy us, and still preserve the context information such that we don't get lost? And it provides more meaning for the focus of the important data. And we have different examples of this in action. We can use multiple coordinated views like we just saw in And we can use different focus and context techniques like color mapping, varying opacity, and varying zoom levels. It's not necessarily a very special algorithm per se, it's just a visual design decision. And I'm going to spam you with just lots of examples of this in action right now. So this is an example of coordinated multiple views that are synchronized and focus and context. So at the top, we have a time series visualization, which is a long duration. The user can select what they think is an important span of time in the overview. That important span of time gets its own window in a zoomed up close view here. So wherever the user selects here, we get the focus in the zoomed in view, and then that same data is plotted in three-dimensional space in the spherical histogram view. These are vectors actually, this data. So we have the x, y, and z coordinates of a vector. So we have amplitude versus time on three plots, time series plots, x, y, and z. Here, we have a spherical histogram that reintegrates those three components together and forms a 3D vector. And the 3D vector is centered at the origin of the sphere. And that corresponds, in this case, to the orientation of an animal. So this data has been collected from an animal like a cormorant or a turtle. Right? You can attach an accelerometer to an animal and then measure their orientation over time, what they do over time. So in this case, the yellow region is the focus. The focus is also rendered in two other views, which are focal views. And this is the context, this overall length of time here in the time series data. So that's one example. I'm going to give you lots of examples now. And they're generally interactive, so it's nicer to show them in, when they're alive and moving rather than in a static slide. So now you can sort of understand why we started the DataViz YouTube channel. It's because interaction is such an important element in this topic, and you can't see interaction in a static slide. You need it's alive, like people are alive, they're moving. So to capture this motion, you really need some dynamic video. And so YouTube is an obvious platform for that kind of presentation. But this is also an example of some focus and context. And in this case, we're seeing streamlines that depict a simulation of a hurricane. So the user chooses a cluster of streamlines, so streamlines with common behavior, and then they're rendered as focus in focus, which means the full opacity. And the context streamlines are rendered with more transparency, and they become the context. So we have focus and context together. And this just happens to be a streamlined clustering visualization. And we will talk more about streamlines and what they are and why they're useful when we get to the third part of the module. But you still get the idea here of how something could be, a set of streamlines could get focus and also context in this scenario. And this is the rugby glyphs example that we just looked at this morning. These glyphs can be rendered in a focus and context style. And somewhere in that video, we show focus and context being used for the rugby glyphs. So these are the rugby glyphs again, and they're sorted in a scatter plot by the time is on the x-axis, but the x-axis can be changed, right? And then the gain is on the y-axis. Those are kind of the default axis dimensions. And this is the user sorting the x-axis by type of play, like line out and kick reception and restart reception, turnovers and scrums. So lineouts, we can see right away, result in a lot of points being scored in scrums. Turnovers, for some reason in this game, don't result in any points being scored. So that's an observation we can make about the game and its strategy in like 5 seconds, as opposed to watching the whole game from start to finish. And here we can see, for example, plays with high numbers of phases can result in tries or points gained. So there's some association here between the number of phases and the points gained. So this is the focus and context part. So the user has chosen a set of events in the scatter plot to render as focus and then keep the others as context. That's the focus and context aspect of this. And that could be useful when the glyphs are overplotted and they occlude one another. And this is the demo that we just saw, so we can apply focus and context to the parallel coordinates, right, where the user selects some of the polylines and they're brought into focus, but the remaining polylines are kept in context. This is another example that we saw, right? So when a user selects a node in the graph, that becomes the focus, and the other nodes remain as context information. Also, you'll notice the edges change as well. These edges change color, and they become focal edges, where these edges don't change color, but they still retain the contextual information. So it's not, like I said, it's not a special algorithm. It's a design decision. Like, what visual elements are we going to keep in focus during the interaction, and which visual elements become context? This is another example. Not is the world's highest quality, a little bit lower quality, but in this case, the focus is all of the vectors that are on this interactive slice or this interactive plane. These are all vectors. There are other vectors in the data set, but we don't render them all because there would be too many. They would occlude one another. The user wouldn't be able to see them all. So we choose a slice through the geometry, that is the focus, but then we keep the rest of the geometry as context, because without that context, we wouldn't know what we were looking at, actually. It would just be completely, well, it would be very, very difficult to ascribe any meaning to the focus without the context in this case. And this is some more examples. So this is kind of a context, and here's a focus and context. So where the focus is this special subset of the flow, we call it the topology, which we're going to talk about more in the future. But the context is the background gray information. Here's another focus and context visualization. This one is also interactive. this texture-based flow this is not focus and context. It's just the context. You see all the flow. There's no special focus here. So it's a lot of information. So that means focus and context is a good strategy for this kind of data set. Here again, it's no focus and context. It's all context. This is a kind of focus and context visualization. A special subset of the flow has been chosen to focus on, so we can see the flow behavior in those two special ribbons or stream surfaces. But we preserve the context of the geometry. So we have the focus, which are the stream surfaces, those formations of flow through the cooling jacket geometry, but we show the cooling jacket geometry as context. So it's a kind of focus and context strategy. Anybody remember what a cooling jacket is? Didn't we mention that in an earlier lecture, or am I just on drugs? Does anybody remember us mentioning that, a cooling jacket? Or was I thinking of a different lecture? Does anybody know what a cooling jacket is? Are there any gearheads in the audience or people that like cars? No? Okay, well, a cooling jacket is a part of the motor engine that draws heat away from the engine block to prevent it from overheating, or cools the engine block. Without that, your car would just overheat and you wouldn't be able to drive it. So that's what a cooling jacket looks like. Here's another example of focus and context. Here we have focus bubbles and context bubbles. So the focus bubbles are rendered at a high opacity, while the context bubbles are rendered at low opacity. This is trying to visualize the behavior of bubbles or foam using a very naive approach. It's hard to really see what's going on there. I mean, we can see what's going on there, but it's hard to cognitively process, because there's so much motion in there, and so many things are moving at a fast speed. It's hard for us to actually process all that information. That's an example of the topology of the foam changing. But somewhere hiding in here are examples of focus and context. I don't remember exactly where they're hiding, but they're in there somewhere. So this is the user adjusting the color map properties of the. So here's the user showing the important regions of the bubbles with the velocity that we're most interested in, and that velocity gets highlighted in the bubble space, right? So that's a kind of focus and context visualization. That color is mapped to velocity, the velocity of the bubbles. So the high velocity bubbles get that brown color that's at the top, right? The higher the velocity is, that corresponds to the color at the top of the color map. This is also an example of coordinated multiple views. So this is kind of a longer video as well, so we will interrupt it. They're all on the DataViz YouTube channel, obviously. Are there any questions about focus and context? I know I kind of went a little bit fast through those, but there's not that much to talk about in terms of focus and context. It's up to whoever creates the visual design, how they integrate that, what they choose as focus, how the user selects focus. It's usually through direct interaction, like direct selection, mouse clicking. that becomes the focus, and then the remaining non-selected visual elements then stay as focus. Okay, I think that will be a good place to end then, if there are no questions or comments. Thank you, everybody.
Do you have any content on data visualization from a financial perspective?
From which
From a
perspective?
financial perspective, like modeling graphs, like stock prices or real estate prices from like demographics and like population.
We did go over one lecture on the hierarchical database. I don't know if you can remember, where we looked at a tree map of the stock market. That was a very classic finance example. But you can find lots of examples if you want to compare things like, I don't know, real estate prices across countries or something like that. I mean, there's lots of data on that. Another interesting website is called World Mapper, and there you'll see lots of demographic kind of information that compares like average income across countries or kind of different financial aspects of but it's a great topic. It's a great topic. Visualization used for business purposes is a very, very great topic. And it's something we work on in the data visualization group.
Okay, yeah.
So yeah, it's a great topic.
I don't know, I just saw some like finance related videos on YouTube, so
Yeah,
I wondered like
yeah.
why we did.
There are some examples on the DataViz YouTube channel of visualization being used for business purposes. You know? So yeah, it's a great topic.
Okay,
Yeah.
thank you.
Can I get your opinion on one
Sure.
of my
Yeah.
So
Let me just say this quickly.